Good afternoon and welcome to this second episode of a tutorial series where we're creating sort of the basics for a base building game using SpriteKit and Swift. And well, let's get started. So, our game so far doesn't look very exciting. If you run it, you only get this blank screen that refreshes at a very impressive 1 frames per second. So that's not much. But what we do have is we have some stuff under the hood. We have a primary relationship in our game where entities perform jobs that somehow change the world. That's basically how you can build stuff. By queuing up jobs that get performed by the entities and then install stuff, change tiles, improve needs to, can do lots of different things. And last time we really focused on just an entity picking up a job and somehow using that to change something in the world. So it's really the primary relationship. Today we're going to make it a bit more interesting because we're going to add requirements for jobs, meaning that to perform a job, you need to, for instance, be in the correct position, or you need to have certain stuff in your inventory, or the place where you want to perform the job has some requirements. For instance, it might need to be empty, so there's a room there to install something. And we'll see that this adding requirements really adds a lot of gameplay opportunities by itself. So this is really an important addition to our system. And in our implementation, what we'll be doing is we'll have jobs being able to spawn new jobs. What that means is, I'll give an example a little further on. We'll work out an example, but it basically means that if a job has a requirement that is not met just yet, the job can spawn a new job that somehow takes care of that requirement, and that job might as well have requirements that need to be fulfilled. And this leads to a situation where one job that you as a player would schedule in the world might lead to lots of sub jobs and lots of stuff and lots of behavior that entities take care of. So it's really a cool system. For now, what we want to implement is we want to implement 2 requirements and 2 subject jobs to really show how this process works. Takes a bit of time, and that's why I'm splitting this one into 2 episodes. In this episode, we'll look at the simplest requirement, that's just being in the correct position, and a job that can meet that requirement, that's simply to move to a location. Next time we will add items, inventories, being able to fetch items and bring them to a certain location. That really adds a lot of additional opportunities, but it's so much work that it warrants its own episode. Now, last time we modeled the jobs on the entity level in a data structure called a stack. And we didn't really go into why we chose that data structure. It becomes important now. And that's because subjobs are basically pushed on the stack. And let me give you an example how this works. Say you, as the player, scheduled a job to change a tile at a specific position, and an entity picked up this job. Now, this job has 2 requirements. The entity needs to be in the correct position, which it is not because the tile is at 1, 0, and the entity is at 0, 0. And the job also requires 2 wooden blocks, but the entity is holding nothing. So none of the requirements are met. There are, fortunately, some wooden blocks in the world available. at a different location. So the entity will spawn a new job and push it on the stack to first fetch some wooden blocks at this intended location. Fetching also has a requirement for position, meaning that to fetch you need to be at the location where the items to fetch are, which we're not meeting just yet. So the fetch job can push another job on the stack, and that's to move to a specific position. For now, this job has no requirements, so this will work, and that means that the entity is able to move to the new location, and the move to job has been fulfilled. Now, when we go, and that one gets taken off the stack. So the next one on the stack is the fetching job, and that now has its requirements being in the correct position met, meaning that this job too can be completed. It's get taken off the stack, and now we are back at the start job, and this job now has one of two requirements met. So it has the items, but we're not yet at the right position because we're at the position where we are fetching the wooden blocks, but not at the position where we want to change our tile. So this job can now spawn a second sub job and push it on the stack, and that's to move to the correct position. This has no requirements, so we can simply take this. This one gets completed. It's get taken off the stack, and we are back at the first job. Now all its requirements are met, so it can be completed. Gets taken off the stack, and we're done. So that's why we were using a stack, because we can place stuff we need to do first to meet a requirement on the stack, and we can keep pushing stuff on that stack as much as we need. And at some point in time, stuff on the stack will get resolved. Those will get taken off, and at the end of, and at some point, the stack will be completely empty again. And then the entity can start looking for another job to complete from the world. So that's why we're using a stack and how this system will work. For today, this means that we're in particularly adding a new data type. We're adding the requirement data type, and we're adding a job call of moving to a location. We're also going to be checking requirements, and we're going to write some tests to demonstrate it's working. So again, this time we're not really concerned with any graphics programming so far. So, and I expect the next episode as well will just be working on the model and writing tests to demonstrate correct working. Open our base builder tutorial. And let's see. So let's start with adding the requirement data type to our model. So we'll create a new Swift file called requirement.swift, and we will model requirements in an enum requirement. And for now, we'll just add a single case to the simplest type of requirement, and that's a position. So now let's add requirements to jobs. So we have our job structure, and let's add requirements as an array of requirements. And let's add these to the initializer, as requirements. But you don't have to pass one in, and if you don't pass one in, we will assume there are no requirements. So we now have requirements for our for a job definition. So let's see how we can use these. So we have our entity, and currently our entity, if it's working on the job, is directly teleporting to the current position. So that's not really intended behavior. So what we will do is we are going to change this around a bit. So the first thing we will do is instead of popping the job we're working on, or we want to work on from the stack, as we did before, we're going to peek meaning that we get the job that's on top of the stack, but we don't change the stack itself. That way, the first thing we can do is we can check the requirements, and we will write a function for that. We have a function check requirements for our current job, and we will implement this in a bit, and it will take the job and the world. And if this fails, then we will log a message: did not meet requirements for current job, and will return. We can put this debug message up front. Now, what we don't want to do is change the position directly here, because we want to use jobs for that. So we're going to take that one away. And now let's implement the check requirements function. So we'll create a new private function, check requirements, that will take a job and the world, and this will return a Boolean value. And the idea is we will go through each requirement in job.requirements. If this goes well, we will return true. And what we will do is for each requirement, we will check if it's not met. And if it's not met, we will immediately return false. So let's see. So the first, we have a requirement here. Let's start see what kind of requirement it is. So we will switch on the requirement. And well, we only have one case right now. That's the position requirement. So what we will see is we'll check if our position is not equal to the job's target position. Because if it's not equal, then we want to return false, meaning we're not meeting the requirement. But if we would do just this and nothing else, then we would never meet this position or this requirement. So what we will do is we'll create a new job, and we're going to push that on the stack. So we'll create jobs, we'll push, and well, we could create a job here for manually, but what we will do is we'll use some convenience functions. So first we need to add a new job goal. We have a job goal move to location, and we will create some convenience in functions so we can easily create move to location jobs in a way that we are sure that they're always the same. So I'll put this in an extension to show that this is something that we added, but is not strictly necessary. So we'll create a static function, create move to location job, and this will take a target position, and this will return a job. We will return a job with the job goal move to location. The target position will be target position, and the build time will always be 1, and this one won't have any requirements. So now we can go back to our entity, and we can say we have our jobs. We'll push on the stack a new job, create a move to location job, and the location we want to move to is the job's target location. We will also log this so we can quickly see that this job has been actually been created. So we have our logger. We'll debug a message out saying entity name created job, and we'll look at the top job in the list. because this returns an optional, we need to wrap it or give the default value. So I'll give you the default value showing nil. So now we have this function implemented. So now we can go through with our work on jobs. So we have checked here that we met the requirements. If we didn't, we return, but we created a new job on the stack. So that's the next one that will be checked. Otherwise, if we are meeting the requirements, then we can continue. And the first thing we will do is we'll decrease the build time. The second thing we want to do is we need to change this code a bit, because we're no longer popping the job from the stack at the start, but we are again pushing the updated job on the stack, meaning that the stack would become larger with more or less the same job, only with a difference in build time. So to prevent that from happening, I basically replace the top item of the stack. We will first pop and then push the updated version. Now there's now also an error here, and that's because we said we added a new job call, and to complete the job we need to implement it here as well. So we have a move to location. If it's a move to location job, then the way to solve it is simply to change our position to the current job's target position. Basically, we're teleporting now as a result of the job. And this should be buildable right now. Okay, but we're not yet sure that this is working as intended. So let's write a couple of tests. So the first test we want to make sure is that if as an entity we're not meeting the job's requirements, then the build time should not decrease. So we have a function called test unmet requirements don't lower build time. Let's see. So we'll create a world. And we will create an entity. And this will be at, well, for instance, the 0 position, and we'll create a new job. Let's see, we want to change the tile to type floor. The target position will be a bit to the right, so it could do something like this, but it might be useful to create a couple of convenience initializers. So let's say I want to have a vector to the right and a vector to the left and a vector going up and a vector going down. So let's see. So our target position will be a bit to the right. The build time will be 2, so we can see it decrease or not. And it'll have a requirement called type position. We'll put this a new job on the stack. And then we will start asserting some values. So let's start with saying, well, we have our entity, we have our jobs, and the top job, the one that's on top of the stack. Let's see, its build time should be 2, because nothing has happened yet. That's what we defined here. Because this is an optional, and I don't really like forced unwrapping in tests, I'll give the default value of 0 here, so that if this is somehow not a value, I still get a nice arrow because this and these two don't agree with each other. Then I'll update the entity in the world, and now the first job should still be 2. And I'm looking at the explicitly the bottom job here because I know that this job might have spawned a subjob to meet its requirement. So not meeting requirements should not lower the build time. There is something sort of similar. What if you are meeting requirements? So we'll have a new test called met requirements should lower build time. It's almost the same, but this time the target position and the position are the same. And now this time both jobs the build time should be 1 lower. And now we can also use this one because this should not have spawned any additional jobs. So let's see if these tests run. This one. Okay, so that's nice. So let's do some additional testing. So one thing that's important to test is if requirements actually spawn subjobs. So let's create a new unit test case class called requirement test. And yeah, here's fine. We will need to import our solution. Can get rid of all these and we can start writing a test. So the first test will be test unmet position requirement spawns move to location job. A bit of a mouthful, but I try and keep the naming of tests as explicit as possible. So we need a world and we need an entity. We can call it example entity. We'll place it again at the 0 position and we'll create a new job. With a job call of change style.floor. And the target position is to the right. It has a build time of, for instance, 2, and it has a requirement of type position. We will put this job on top of the stack of the entity, and then we can start doing some assertions again. So let's see, the top job build time should be 2. And again, we need to give it a default value. Then we'll update our entity in the world. And now the number of jobs should be larger than 1 because there should be 2 jobs now. Also, let's see, so we should have a top job and if there aren't any jobs here, we will fail the test saying there should be at least 1 job, at least the one that we planned there. So then we can return because further testing doesn't have any value. What we can do is we can switch on the top jobs build job type, and let's see if it's move to location job, that's fine. Then we'll just continue. If it's anything else, we will fail the test. The top job should we move to location job, meaning that we indeed spawned from this job, move to location job. So let's see if this test is successful. That's nice. And now let's see if the other tests are successful as well. Okay, so not all are successful. So that's now it's interesting to see what's going on here and how we can debug this. So we are getting an assertion that failed. Apparently, somehow there is still a job here, and we expected there to be no job because we should have completed the job right now. So let's see what happens. It's a nice time to also show how you can look at the logging that we create. So let's see. So you can use the console application for that. You can start logging. This will quickly give lots and lots of jobs, but we can narrow it down a bit by going to our app delegate and looking at what our subsystem is called. Then go to console search, and instead of random, we choose for a subsystem. And what we can do is we can run the test again. And then we can see what is happening here. So it's working on the job change tile, it's working on the job change tile, and it's finished the job change tile, but it's somehow still there. So let's look at the entities job code, and we complete the job here. And we're never taking this job off the stack when we complete it. So when we don't complete it, we replace the top stack with an updated version of the job. However, when we complete the job, there's nothing here that takes a job off the stack. I mean, because we're not longer taking it off here, we're just looking at the top of the stack and not popping from the stack. So what we should do is we should, as part of completing the job, pop the job from the stack. And I'm using this syntax, I mean, because you can just do jobs.pop, but you get a warning because you don't get a result. You're not using the result. For me, that's fine. One way of solving that is using this syntax. That tells the compiler we understand this function returns something, and we don't mind that we're losing the result. So let's see if that helps. See, this one is now green. Would this also help for the other one? Let's see. Okay, so these ones are now okay. So our tests now complete successfully. So let's see. So that means that we achieved our goal for this session. We also looked at viewing logs using console. And next time we will look at implementing item requirements. And there's a bit more work because we need to implement an inventory. We need to add items into the world. And we need to add behavior for fetching and consuming items. So this is a nice topic for the next session. And in the one after that, most likely we can start doing some actually graphical work where we're going to show our world on the screen. So thanks for watching and have a good day.